Hi everyone. So in this video, we're going to go ahead and talk about Charles's law, which relates volume and temperature. So let's go ahead and get started. Okay, so Charles's law tells us that volume and temperature are proportional when we hold the pressure and the number of moles constant. Said another way, as volume increases, temperature is also going to be increasing and vice versa. So as temperature decreases, volume will also decrease. Those two things are linked together. So if we go ahead and graph this, we see that we have a straight line. So we have a linear relationship between the two because as one increases, the other one also increases and vice versa. So the equation for Charles's law is V1 over T1 is equal to V2 over T2. Like before, the ones stand for the initial values, the twos stand for the final values. V stands for the volume, which can be in pretty much any unit, and T stands for temperature. But one important thing here, we have to have the temperature in Kelvin. This is because we can't have negative temperatures. That messes up our whole volume and everything like that. So make sure that you are converting any temperatures into Kelvin if they're in a different unit like Celsius or Fahrenheit. So a real life example of this is balloons on a cold day. So if you fill a balloon inside a building and then take it outside on a cold day, it's going to seem to deflate. It's going to get real sad and start getting droopy. But when you take the balloon back inside, it's going to seem to reinflate as the gases expand out. The lab examples of this, specifically the balloon in the beaker of hot water, because we weren't changing the pressure or the number of moles, that caused it to expand as it warmed up. And when we put the balloon into the freezer, caused it to shrink, just like when we do that in real life. So let's go ahead and work through some examples. Okay, so let's work through some examples of Charles's law. So for our first example, a 600 milliliter sample of nitrogen is heated from 27 degrees Celsius to 77 degrees Celsius at constant pressure. What is the final volume? Okay, so if we think about Charles's law, it's V1 over T1 is equal to V2 over T2. But the key thing here is, remember, my temperature must be in Kelvin, not in Celsius. So I'm going to need to convert those two temperatures. The other thing we want to think about is our paired values. So we're told that we have 600 milliliters, and that is at 27 degrees Celsius. So those are going to be our paired values. That's going to be our ones. And our twos are going to be our 77 degrees Celsius once we convert that to Kelvin, and then the final volume. So let's go ahead and write some of this down. So our initial volume is going to be the 600 milliliters. Our initial temperature is going to be 27 degrees Celsius, but we need to convert that into kelvins. The way we go from Celsius to Kelvin is we add 273. So when we go ahead and do that, that brings us up to exactly 300 Kelvin. Our final volume, that is our unknown that we are trying to find. And then our final temperature is the 77 degrees Celsius plus the 273. So that's going to equal 350 Kelvin. Okay, so let's go ahead and start to plug in our values. So we have 600 milliliters, that is our V1, over our initial temperature, which is 300 Kelvin, which is equal to our final ratio of our V2 divided by our T2, which is 350 Kelvin. So for this, we're going to cross multiply and then divide. So we're going to take 600 times 350. So don't forget your units. So we're going to have V2 times 300 Kelvin. So to get the V2 by itself, we're going to divide both sides by 300 Kelvin. Okay, so if I look here, my kelvins, they're going to cancel out with each other, so I'm going to be left with units of milliliters. I see right now I can go ahead and simplify 600 divided by 300. That's the same as 2. So really I'm taking 2 times 350. So my volume is going to be 700 milliliters. And feel free to put that in your calculator if you need. There is no shame in doing that. Now, I do want to think about sig figs for a second. My initial values, I have 1 sig fig here because I don't have a decimal point. I have 2 here, and I have 2 here. So I want to go to the least number of sig figs, which means 700 milliliters with no decimal point is the correct answer for that. Okay, so for the next one, it is a you try, meaning I want you to try it on your own first. Okay, so go ahead, pause the video, try this on your own. Don't forget to convert the degrees Celsius into Kelvin, and then when you have your answer, come back and go ahead and play the rest of this. Okay, so let's go ahead and work through this. We have our paired values, our initial values of 280 liters and 27 degrees Celsius. Those are our 1s. And then it is heated to 35 degrees Celsius. That's going to be our 2. So let's go ahead and start writing this down. Our V1 is equal to 280 liters. Our V2, that is our unknown. Our T1 is equal to 27 degrees Celsius, but we need to convert that to Kelvin. So again, we're going to add 273, which gets us up to 300 Kelvin. And then for our T2, we have 35 degrees Celsius, and we want to add that 273 again. So that gets us up to 308 Kelvin. Okay, from here, let's start plugging in our values. So we have 280 liters divided by our T1, which is 300 Kelvin, and that is equal to our V2, which we do not know, divided by our T2, which we do know. Okay, and again, to get that V2 by itself, we're going to cross multiply and divide. So 280 liters times 308 Kelvin is equal to V2 times 300 Kelvin. So to get that V2 by itself, we're going to divide both sides by 300 Kelvin. So if we look at our units, our kelvins are going to cancel out with one another, so I'll be left with units of liters for this problem. So we go ahead and plug this into our calculator. This one isn't as easy to do mentally. So 280 times 308, and then divide that by 300. So that gives me an answer of 287.46 repeating. So we do need to think about sig figs. So if I look here, this has 2 sig figs, 2 sig figs, 2 sig figs. So I'm going to round my 287.46 repeating up to just 2 sig figs. So it's going to end up getting chopped off between the 8 and the 7. 7s, I'm going to round up. So my answer for this question is 290 liters is my final volume. So I hope that helps. If you have any questions, please let me know. Otherwise, have a great day, everyone. Bye.